grading stuff. It's like, it's not going to kill me if I don't have to grade on them. I got everything else done. So.
Yeah. So then, like, whatever, just grade.
Yeah, same. I mean, honestly, all I have is freaking variables and things, and then I'm done. I mean, I suppose at work, you hang around in the lab, just downstairs, Carton and Darwin, and pretty dumb too. I figured. Well, okay, that's not a bad idea. I'll probably just look over your shoulder. I need to start learning from one. Right, it's there. It's like directly across from us right now. Yeah. If you come with him down, I'll be there, and then we'll be heading up there around 7. So you just hang out with us. You come along. It's not like this piece is like, oh, I know exactly where to go. The Dean has to bring me.
Nothing much.
I think when Bob speaks, I'll take the paragraph of
David.
But actually, for some farmers was there.
Yeah.
I talked to the guys. Oh, yeah, I read a bunch of pages in social media. Perfect.
Is that for an individual agent, though?
Yeah.
Yeah, that's.
See it?
Yeah, it's really, really good.
Is it? I mean,
It's all like one's a timer, one's a mentor, one's a
seriously?
Really?
Yeah.
Haven't.
I'm so excited for today's
Computer
quiz.
Colloquium for a little bit and
So,
review.
Excellent.
where'd you get your sandwich?
Matt.
Well, it's already 12, so goodness. So where do I need to position my computer?
Put it somewhere here.
Okay.
There's a microphone. You'll be on YouTube tonight.
Oh my goodness. Well, I'll have to check the number of hits. Can I move the microphone? Better not to, huh? Oh, it's long enough. I'll just...
Well, while we're getting set up, I wanted to alert you to the fact that next Thursday we'll hear from one of our own, Professor Franz, emeritus from Faculty Department over there. He's going to talk about how to publish your own book on the internet. But today I have the distinct pleasure of introducing you to Professor Emeritus Kenneth Louden from San Jose State. He was chair of the department there at San Jose State for
4 years.
4 years,
One term.
one term.
Like a one-term president, you know. It's good to get out.
Here at Sonoma State, it's 3 years for a term.
Oh, is it?
Yeah.
Okay.
And I was chair for 10 years. 3 and 1/3 terms. Anyway, Professor Louden is going to enlighten us as to why some programming languages are weapons of mass destruction. So, and which languages to avoid. Let's welcome the speaker.
Thank you. I also want to thank Professor Louden for inviting me and giving me the opportunity to talk here. And also, this is delightful because it's my first visit to Sonoma State, which, as I saw walking around campus, had its beginnings in 1961, which was the year I went off to college. So that rang a bell with me, and I thought, geez, I kind of just missed going to Sonoma State, because they just started that year, and if I had heard that they were starting, I might have come. Actually, I was on the East Coast at the time, so that's all belong. Okay, let's see if I can get signed in and see if I can get the, well, there it is. It's working already. So, except that I'm right in front of it, so I guess I need to move over, don't I? So, let me do that. And move this microphone here. Wow, that's huge. So, let me see if I can manage to not stand in front of the display here. Okay, well, that's interesting. This is not the optimal screen resolution for the clone display's configuration. The optimal resolution is 800 by 600.
It never is.
Notification for more information. Well, should I leave it or should I switch to 800 by 600?
It doesn't seem to be stretched or anything, and I can just barely make out the pixels, so it seems to be fine.
Well, okay. What happened is on my screen, of course, it shrank So because of the ratio, which on my screen is the widescreen ratio. So it's going to take me a little bit to sort of see where I am here. Okay, so let's just leave it the way it is.
Yeah,
If it ain't broke, don't fix it.
yeah, exactly.
And let me start by finding my slides. Okay. All right. The colors are a bit washed out, but that's probably a good thing. Okay, well, this is not going to be tremendously deep. These are just going to be some thoughts that I was thinking about a little bit the last several months. And also I have one colleague who is very interested in this stuff too. And I'll mention his book because I think it's an interesting book. And it's basically about programming languages and their relation to the quality of software. So it's not really going to be about horrible, dangerous programming languages, I guess, so much as it is about what do we expect from a programming language in terms of safety. And what do we mean by safe in this case? We don't mean sort of internet safety as in, can you break into it or anything like that? Really, we just mean, does the language promote correct programming? That's my idea of safety here. And does it promote software reliability? So let me just mention a couple of things here, and I've included my two textbooks that I've written. This one is a little historical now, but amazingly is still in print and still selling. This is a new edition of my programming languages book, which was a collaboration with a second author, which you can't quite see there, somebody named Kenneth Lambert, who has the same initials as me, so that was a source of great confusion while we were editing, because we both signed KL. I was at San Jose State University from 1985 to 2010, 25 years, and enjoyed most of it. Toward the end, it became a little wearing because of the financial stress, which I presume from the headline here, budget deficit, that you're suffering up here too. Who knows when or if that will ever get fixed. But certainly, probably not anytime soon. This is the abstract to the talk. It's blah, blah, blah. Relation to programming effort. This is something I wrote also last October, so the talk itself has drifted a little from that. So nevertheless, I hope that you will be able to get a few things out of this and remember at least one thing that I talk about here in your future careers. And for those of you who are computer science students, how many are computer science majors here? Wow, terrific. And a nice audience, too. Thank you for coming. So the language history I want to talk about is the sort of the mainstream ALGOL-based language development history. Has everybody heard of ALGOL? Yes.
I've
You've
heard
heard
of it. Don't
There are-
know much about it.
Okay. Fortran, of course, was the very first language. It's the language everybody loves to hate now, but it's actually still in use. Not well designed because in those days they didn't know anything about designing programming languages. However, computer scientists learned fast, and the ALGOL family of languages came very closely on the heels of Fortran, rather amazingly closely. There was Algol 58 to be replaced by Algol 60. And Algol 60 is kind of the predecessor of almost all mainstream modern languages. And still a language that people in Europe particularly truly love. Simple, straightforward, not much in the way of software engineering principles built in, like no modules, nothing like that. Everything had to be compiled in one massive unit. So in that it shared with one of its successors, Pascal, which died a slow and lingering death over the years until it was replaced by currently object-oriented languages, C++, Java, C#. These are the languages that we mostly use in the Algol tradition today. C was a bit of a black sheep because as these languages progressed, they became more and more, shall we say, restrictive in terms of requiring the programmer to write explicitly more and more in the way of declarations, types, and things like that. And that's really what I want to focus on now. AIDA in particular, a language that still exists, but really on the margins. Even in the U.S. military, which is what AIDA was designed for, nobody uses AIDA very much anymore, except in very special circumstances. And as I was just saying, the Algol tradition was that as the language development progressed, the languages became more and more restrictive, except for C. Yes?
Are talking about KNRC or ANTCC or 89C?
Well, now that's a very interesting question because it is true that even C became slightly more restrictive with 89C, and then there's a subsequent standard too, I think, 99C.
But it doesn't change like the type interface. It more basically standardizes what was formerly just good practice.
Exactly. The Kernighan and Ritchie C lacked a whole bunch of stuff which crept into the language later and then was codified in the 89 standard. And the 99 standard went a little bit further in requiring certain type errors to be more than warnings, which was a slight sort of bow to the restrictive side of the programming community to make it a little bit more restrictive. But of course, I think C in its very heart, in its very soul, is a non-restrictive language.
You can still mess up the stack frame if you want.
Yeah, absolutely. You can still wipe out memory, as many of my students did. That's why I use a different computer to... So C is an anomaly, and it's still very dearly loved today, I think, in part because of that. So we'll get to that in a minute. Okay, so let's talk about some safe languages here in the sense of restrictive. So there's a picture. Anybody know who that is?
Is that you?
No, it's not me, but I guess it could have if I were to kind of wrinkle my brow a little bit.
Is it Tony Hoare?
It's Tony Hoare, yes. Otherwise known as C.A.R. Hoare, or as he's called now, Sir Charles Anthony Richard Hoare, C.A.R. Hoare. He was a huge influence on the development of the Algol family of languages. He, together with Niklas Wirth, or Wirth, as one should say perhaps, his being German, developed Algol W, which was rejected by the Algol Committee, and they went on then to design Pascal, much as in the wake of that rejection. He's still alive. I think he's in his 80s. It's amazing, isn't it, how many of the really early guys still are around, and you can still ask them questions if you get a chance. He advanced this very influential idea that a language should be as restrictive as possible. And he enunciated that in the following quote: maximize the number of errors which cannot be made, or if made, can be reliably detected at compile time. And of course, reliably detected means, of course, then that prevents your program from running, right? Very strange, but last year in a public lecture, he apologized for inventing the null reference. And I had to think about that for a while, because I'm not quite sure how you would do without the null reference. Of course, what that's talking about is, null in Java, right? The reference to an object that doesn't yet exist, or may not ever exist, right? So it's a pointer to nowhere in memory. And of course, such a pointer cannot be dereferenced without causing a runtime error. Null pointer exception, right? Which I'm sure many of you are familiar with. When you run off the end of a linked list, right, you get a null pointer exception.
Always check for null.
Absolutely. And make sure you check it before you try to dereference it. If you're checking it at the same time, and that's actually the reason for another little quirk of programming languages, which is the short circuit evaluation of tests, right? Everybody knows what that is? Where you check for null first, and then if that test fails, it does not go on to try the dereference. But he considers this to have been a terrible, terrible mistake, a $1 billion mistake. What would he have put in place of it? I didn't have the time to really go and listen to his whole talk. If it in fact exists on the web, I just found this quote and was astonished by it. But what would you do if you had no null reference? You would have to create an area of memory with some kind of tag on it that would indicate this really isn't here, all right? And then test for that instead. But at least it would be a valid reference, right? AIDA and to a certain extent Java are the best examples of this view. Java can be quite annoying and restrictive. I shouldn't say annoying. I'm betraying myself here. But it can be quite annoying and restrictive because it is designed to be as safe as you want it to be, shall we say. What are the main ideas for encouraging or ensuring safety? All names need explicit declarations. All names and values must be statically typed with structure known in advance. Operations can only be applied to specific types and are checked in advance to see that they make sense. And programs that don't pass cannot be run. It requires a lot of explicit programmer specification. And all potentially unsafe dynamic operations have runtime checks applied, such as the null reference.
Reminds me of everything QBasic doesn't have.
Well, sure, gosh. People still program in QBasic?
No, that was the first programming language I learned.
Oh, okay. Well, that makes sense if you learned it in high school, which is likely, yes?
No.
No?
I learned it in elementary school from my dad.
In elementary school, wow. Terrific.
But yeah, if you mistyped a variable, it would think you're just creating a new one.
Oh, yes. And then later on, sometimes much later on, after 20 minutes of execution, suddenly it crashes.
Programs weren't that complicated.
And that's one of the things that declarations were supposed to assist with, is to prevent that runtime crash that is the dread of every programmer and your data is all gone, particularly if it's in production and that data cannot be retrieved. So I'm just going to throw this up. Everybody knows this, right? The Hello World program in Java, which to a non-Java programmer looks really obscure because of all of the stuff around it that it has to specify. It has to specify a class name, which has to be uppercase. It has to have a main method, static, public, void returning main method, which is not capitalized. And it has to have an argument, which is an array of strings. And then you have to send this hello world string to the system printline function. Actually, there is a printf function now in Java that you probably would prefer to use, but this is old style Java. And of course, it's got to be in a file, which has to be precisely named with the same case requirements as the class. Otherwise, the compiler will choke and say, I'm sorry, your class name does not agree with your file name. I never completely understood why that requirement was put in there, but I suppose I can. It's so that you really don't have to depend too much on the file system. You keep track of two separate things, files and programming. So here's the other side of the tracks. And I love this picture. I just pulled it off the web the other day because this is precisely the difference in these languages. Okay, let's go back a second here. Tony Hoare, the intense stare, the drawn eyebrows. We don't want you to do anything bad here. The moralist, and this guy, who is not John McCarthy. John McCarthy last passed away just a couple months ago after an illustrious career at Stanford and MIT. Does everybody know who John McCarthy is? The inventor of...
Is he a student of one of the inventors, the inventor of lambda calculus?
I guess that's right. He did, I think, study with the mathematician who developed the lambda calculus in the 30s. Church, Alonzo Church, at, where would that have been, MIT?
MIT.
But McCarthy is best known to computer scientists today as the inventor of Lisp, which is a permissive language.
Also AI.
And artificial intelligence. But who is this? Very California looking, right? And indeed he is a Californian. And he invented also one of the most amazing languages in the other side of the tracks, which is the permissive side. Anybody know who that is? No? Alan Kay. Has everybody heard of Alan Kay? He worked at Xerox PARC in Palo Alto, or Menlo Park, I guess. And he's still very much alive today. I don't know how old this picture is. It's probably a few years old. He's probably a little older than that now. But he was the ultimate California guy and invented Smalltalk, which is, again, one of the very permissive languages, which don't require declarations if you don't want to make them. Then let me list a few more here. And it's kind of interesting because there are lots of them, and they're all 20 years old or less. And so that's an indication in itself that the world of permissive languages is growing, not shrinking. And the world of restrictive languages has kind of stagnated, shall we say. Java, C++, C#, as much as these are, C derivatives, of course, are less restrictive. But we have some really interesting languages here: JavaScript, Python, Ruby, Lua, Scala. Scala is perhaps the most interesting and most recent of these languages. And these are some names, some of which I didn't know myself, and I looked them up.
There's the curly bracket family.
The curly bracket family. Not quite sure.
Oh, there are languages that use curly brackets like C and Java.
Sure. Some of these will let you use curly brackets, but don't necessarily require it. So the main ideas for these permissive languages, I like to think of them kind of as California languages. Minimal syntax, no static checking. Every program can be run, or almost every program. Execution can still be safe in the sense that every time it comes to an operation, it checks to see if that operation is legal. But, of course, that's going to be the source of many runtime errors, and we dread runtime errors, right? More than compile time errors, if there is a compiler. So I just wrote down some Hello World programs here. JavaScript was kind of fun because the actual JavaScript here is just in here. This all is HTML wrapper for the JavaScript, because just in case I felt like it or needed to or somebody wanted me to, I made it so that I can put this in a browser and run it right here if we need to. So that's JavaScript. Then we've got Python. Sorry for the animation problems here, but I struggle enough with PowerPoint, and I didn't want to struggle more than I had to. Python, very easy. Ruby, very easy, except for the put S maybe. What do you think that means? Put S.
String.
Put string, yes. So there's a little bit of type checking going on there. Notice that there are no curly brackets. And again, Lua is exactly like that. Here's Scala, and here we have two different versions of the program. One without curly brackets and one with curly brackets. And it depends on whether you're using really the interpreter or the compiler in a system. If you're building a large-scale system, you want to define it like this so that you know something about its name and can refer to it elsewhere. If you're just interpreting it, you can just do this. So here's a language that lets you use curly brackets if you want. So, our safe language is really safe, though. You know, if it compiles, is it going to run and run well or not? Well, you could try correctness proofs. That was something that computer scientists were really hot on for a while. But the problem with correctness proofs is they're incredibly complex. They really are doable only in toy cases. They depend on a formalized specification. What if the spec is wrong?
Sometimes the spec is basically the program itself.
Well, that's the school of there are no bugs, there are only features. The program defines itself, so whatever it does is correct by definition, right?
Then it's the right program.
Well, sure.
You want one without this feature.
So, can you make a program truly safe? Well, nobody has convinced me that you can truly make a program safe. I/O is always a problem. Garbage in, garbage out. Well, that's anathema to somebody who wants a reliable program. You want garbage input, graceful exit, right? What I might call the Guy-Gee principle or something like that. You definitely do not want the program to produce garbage if it got garbage as input. One of the things I used to do, and it used to really annoy my students, is that one of the first things I would do when creating programs is try all kinds of garbage on the program to see if I could get it to crash. And of course I generally could. Causing great gnashing of teeth. This is just an exercise. It didn't say we had to make this bulletproof. Massive exception handling still necessary to produce reasonable behavior. Yes, so a lot of exception handling. It's amazing how many people still write programs that have virtually no exception handling. And then, of course, we've got the famous software disasters. And I just picked a selection here because I'm not going to try to prove anything statistically. I just thought these were amusing. Well, not amusing to the people that they happen to, but and maybe they shouldn't be so amusing to us. Maybe they should be sobering to us. And I picked some that were well-known and some that were less well-known, just to give a cross-section here. Everybody pretty much knows about the Ariane 5 disaster. And there's the Patriot missile disaster, too, which if you were alive and thinking about things back in 1991, you probably are pretty much aware of as well. Less well-known, but not unpopular, is the Soviet early warning system disaster in 1983, or almost disaster. And the AT&T phone network disaster of 1990. So that's 4, and then the Mars Planet Orbiter in 1999. So those are the ones that I just picked out more or less at random because I thought they were kind of interesting. So let's look at each one of those in turn. Ariane 5's first test flight, June 4th, 1996, failed. Self-destruct 37 seconds after launch. And so the reason turned out to be quite astonishing. The Ariane 5 developers borrowed a bunch of code from the Ariane 4. The Ariane 4s and the Ariane 5's computers were entirely different. Ariane 5s were 64 bits, and Ariane 4s were 16 bits, or maybe 32, I'm not quite sure. I think 16. The software was written in AIDA, one of the most restrictive languages there is. And however, for efficiency reasons for the Ariane 4, they left some exception handling out, with the idea that that would save some cycles. Not realizing that the Ariane 5 people were going to borrow this system, lock, stock, and barrel, and run it in the Ariane 5. And then also the system that had these gaps in the exception handling were actually unnecessary in the Ariane 5, but rather than have to pull them out of the Ariane 4 code, they just left them in there because they were afraid if they pulled them out, something else might break. And they let it continue to run, and it, alas, crashed and ended up destroying the entire Ariane 5 rocket. So here we have the most restrictive language of all being misused in a certain way. And that led to a huge disaster which cost millions and millions of dollars. I think I've heard the figure $500 million, actually. The Patriot missile disaster, this was in a sense even worse because it caused loss of life. 28 soldiers were killed as a result of a failure to intercept a Scud missile fired by Saddam Hussein. And the reason turned out to be a time calculation that was inaccurate in that after a long period of time, there was a rounding error that crept in. And you can think about why did that happen. I just mentioned here that multiplication by 1/10, then you should have a suspicion right there already. 1/10 is not a finite decimal in binary arithmetic. It is an infinite repeating decimal, and that's where the error came from. And after 100 hours, the time, the computer time was so big that multiplying by that brought the round-off error way up to a point where it was, well, not much, on the scale of things, less, just about a third of a second, but that was enough to mean that it was 600 meters off because of the speed of the missile. It's not that it actually missed it. It never even fired because it couldn't find it. It was so far off that it actually couldn't find it to shoot it at the time. So that ended up with 28 soldiers losing their lives. Well, what kind of code was that? We'll talk about that in a minute. Then there was the Soviet early warning system in 1983. You know, it's amazing to me that people aren't more grateful to the Soviet Union, because here was a case where a Soviet duty officer essentially saved the world by ignoring a false reading that the early warning system provided.
A doomsday device was an operation.
It was like a doomsday device. If any of you have seen Dr. Strangelove, that's in my view, a great movie.
But their semi-automated doomsday device was only operational in '86.
That's right. It had his finger on the trigger, so he could abort it. In fact, he reported it as a false alarm. So he had the ability to decide whether it was, and there was a good reason for that, because this was quite a buggy system. But it was the only system they had at the time, and they were so fearful of an attack that they had deployed it anyway. And I don't know the true nature of the bug, because, of course, this software from the former Soviet Union I don't think is readily available these days. But he's become a bit of a cult hero for having refused to launch missiles against the U.S. for this reason. So I say that we really owe the Soviet Union thanks, because this, I think, was the second time that the Soviet Union had saved the world, the first time being in the Cuban Missile Crisis. So when one is led to wonder whether our government would have saved the world too had the chance, and the answer is probably not. The AT&T phone network, well, that was in 1990, and here was C code rearing its ugly head. It was a buggy piece of C code that was never tested, that was let loose, and because of a cascade of horrible Murphy's Law phenomena, ended up bringing down the entire AT&T system. And the code was, do I say what the story was with the code here? No, I guess I say it later. And it was actually the protection code, the design to protect the network, that eventually brought the network down. So kind of ironic, if you will.
Air handling code should be the most rigorously tested for errors.
Well, sure. It wasn't really errors, it was just protection code. You know, if you have a site that's failing, the idea is that you want to protect all the other sites that are communicating with it from failing as well. Yes?
Wouldn't you want to test it? I mean, if you produce something that saves people, you should test it first.
Well, sure. It was a complex upgrade. This was a very, very minor piece of the upgrade. It slipped through, as it were, because people weren't paying attention. It was a piece of code that had never been executed in their tests. There are lots of cases of that where somebody doing an upgrade will introduce a bug, and that bug will perhaps not be found for 10 years, and then suddenly that's the first time that code ever got executed, and suddenly there it is. In this case, it happened a little faster, like the next day. But you can understand how in a pressure environment with lots of things going on, something slips by. Fortunately, it didn't cause any loss of life. It only caused 100,000, 200,000 airline reservations to be lost. The Mars Climate Orbiter, again, it crashed, and the spacecraft fell into the atmosphere and crashed. And the discovery later was something that, again, never should have happened. The code for the thrusters was using pounds, and the spec by NASA said they should have used newtons. And the operators at the Jet Propulsion Lab were putting in newtons into the computer of the machine, of the orbiter, and that resulted in a miscalculation and a crash. So here we go. AIDA, a very strong language. Still it failed because of institutional errors, shall we say. Patriot, that was legacy assembly code. So you could say, all right, it was assembly code. Anything can happen with assembly code, right? But why were they using it to protect lives? And why was it legacy code that had never been corrected? In fact, if you go really to the description, it had been corrected in some spots, but not others. And the correction for the spot that caused the deaths came in the next day to that Patriot site, so they missed it by a day. The Soviet warning system, the phone network, C update code not sufficiently tested, and the climate orbiter, again, kind of an institutional failure because they never caught the error that it did not meet the spec. So, really only in one case would a stricter language have helped those situations. The C code, what was the problem with C code? Well, it was a break that the programmer used erroneously to exit an if statement. Remember, in C, you can't exit an if statement using a break, right? You can only exit switch statements and loops with a break in C. And he had accidentally, spaced out, used a break inside of an if. It broke out of the entire switch statement and crashed the program. Why are we still programming in C anyway? Good question. Because of all the ways we can avoid strict checking. Void, stars, casts, arbitrary jumps, all the stuff. So.
Very fast.
Well,
get
you
down to
say
the core
that.
of
You
the
say that.
architecture.
I'm going to come back to that right at the end if I can get to the end here. I see I'm rapidly running out of time. So, I've vowed not to do this at the beginning, but like all professors, I'll start going faster toward the end, right? So, you can make languages more flexible. You can use generics and templates. You can use things like layout rules instead of commas and semicolons. You can use a type inference engine. That's actually pretty interesting. To use a type inference engine, you don't have to state the types. You can run a program that will actually calculate what the type has to be for the program to be correct. But these things are all, generics and templates, I guess, are pretty common. They have their own problems. But a lot of this stuff is not very common. So, you can use a dynamic language, but then the big thing is that you have to test. And you have to test really intensively to avoid all of these horrible execution errors that you would get as a result of using a dynamic language. And there's a lot in testing that we don't have in curricula these days, particularly as it regards something. I'm going to skip over this. This was a program that a friend of mine wrote named Ron Mack, and he wrote a book about it. And it was a hugely successful program, and it was a program that was involved in the Mars rovers. And as you know, the Mars rovers was one of the most successful missions ever accomplished by NASA. And there are a lot of things to be learned there. But I'm going to focus on this, and that is test-driven development. If you're going to use a dynamic language, it always makes sense to figure out how you're going to do testing. And test-driven development says always test, always write the test before you write the code. And in fact, you should never write more than a few lines of code without already figuring out whether it works or not. Something we always do in classes, right, is you write 5-10 pages of code, and that's when you start to test. once it clears the compiler. And the idea here is that you don't do that at all. You always write code after you have written the test, and you always try to get the code to work as quickly as possible. Always build on top of working code. Get it working as quickly as possible. Make changes after you've gotten something working. Build early, build often, log everything, and know when it will break. This is kind of a regime that nobody uses, at least not outside of the test-driven development community. And CS programs reflect that. You know, we always teach testing at the end of the course, and that encourages us to think that testing is something you do after development. And no required course on testing, even no testing course at all. You get some in software engineering courses, but not a lot, and not to the extent that you really want to emphasize that. So I did a little survey the other day, and in the CSU system there are 22 bachelor's programs in CS, and 5 have an elective course in testing. I was actually surprised that there were that many. None, of course, have a required testing course. In a BSSE program at SLO, there is a required testing course, but it's in the software engineering program, not the computer science program. So maybe that's a distinction between those two kinds of programs. So what am I going to say here? Apparently there's little relationship between language strictness and program reliability. The use of a permissive language in test-driven development are separate issues, but seem to go well together. There's a lot of evidence for success, but it's still anecdotal. If anybody wants to do a real scientific study, it would be great because nobody has done one. Separate Q18 is probably a mistake. You know, how many companies have a quality assurance department, and all the programs have to be funneled through quality assurance? It's probably a mistake. Programmers should do testing. They should do unit tests. And then users should do the testing. Having a QA team come in and say, here are all the errors that you made, what does that encourage? It encourages fear, and it encourages adversarial relationship during testing. Not a good idea, actually. We should buy into the testing process. And really, organizational issues are probably a lot more paramount than the programming language. And efficiency should not be a criterion. Okay, why is that? Well, these days, we have learned how to make programs really efficient. Java runs faster than C in most cases. How is that possible with a JVM in between the machine and the program? Well, all of the stuff that we've learned to do. Just-in-time compilation, that kind of thing. Making sure that we focus on the things that really need to run fast. And thank you. And I went 5 minutes over. I hope that's not a disaster. Can we all get out of here in 10 minutes? Questions? Quick questions. Yes?
What's the Java virtual machine written in? What's that Java camp?
Well, you know, I think in many cases it's C or C++, right? So there you go.
Did you know that the C standard library is usually made out of assembly?
That doesn't surprise me. You know, somewhere assembly has to come in. Yes.
What's the name of the gentleman that wrote the test-driven development book that you showed?
Kent Beck.
Thank you.
Mm-hmm. He's a colleague of Martin Fowler, who people might recognize as the inventor of extreme programming. Any other questions? Okay, well, thank you very much for... Oh, there is one. Here's one.
I think the newer languages that are more flexible because maybe part of the reasons because the developers have gotten better, so that the errors that used to happen.
I absolutely think that that's true. And IDEs often will have a checker that will statically check automatically So you can still blast out the code. You don't have to worry about types. You don't have to worry about variables. And then you can run the checker, and the checker will say, hey, it looks like you screwed up here. But the big difference there is the checker isn't going to tell you for sure you can't run the program. Okay.
Well, thank you.
Thank you.
Put everything in so we can move.
Yes.
I got a text that went out. A text that went out. That's true. Right? No, I got this one. Have my name on it? Yes.
Here you are, sir.
I mean,
Thinking of 26? Yeah. Do you want to get together?
Yeah, it's probably not a bad idea to have some generated, right?
Okay, I'm ready.
Let's go.
Hopefully my phone,
I occasionally, I mainly use C++, but I use C to maybe write some functions.
looking forward to hearing you talk.
Slinking is a Pokemon whose defining characteristic is has ridiculously high HP and attack and pretty good other stats. Like its other stats are pretty solid. But except for it, and by good attack I mean completely functional, not so long, which is ridiculous. There's only 2 Pokemon that have better attack, and they're both also really terrible. But it has an ability called Truant, which is every other turn, it just does nothing. Like, you attack with it, and then the next turn, if you don't switch out, it just sits there and does nothing. It's really awful. However, the end result is, you,
So they could get sandwich.
I might not do it. You do it. Basketball. Let's do it. Well, I'll get my friend Sam. Maybe off there. I was thinking like Kyle or sandwich. Or Kyle's good at basketball. Yeah. I got a test back today for investments. Oh, how'd you guys do? 105%. You did?
Did you even get that one?
I got it back. I said I got one. Yeah, 39 out of 40.
How did you do?
37 out of 40.
You thank God you're not in the worst class.
Yeah. Back-to-back semesters of having his classes, I think I go crazy.
So I reported 2 out of 40, and we got a 40.
It's awful.
You want to push up some material?
Pretty much.
Kind of a lot. It's just kind of from accounting and money and banking. So I was able to do like educated guesses. That's not the best.
Yeah. It's nice.
Wow.
So, but it just because last week, it was brutal. So a bunch of us
I was really
yeah, because you were complaining about the workload. Did I ever tell you about that story about the girl who complained about fractions and so on the test? I do. So
You can't complain with them because
no, because he punishes you.
Right.
So you got another one today. The penalty's going to be just as bad or worse because you can punish.
Really?
This is our punishment.
What's that? That's horrible.
Yeah, but this is what happens. This is how tyrants happen. You give somebody a little bit of power. It's I mean, I really want
and his microecon, his 305 class was just, that was pretty tough. And that was just a low 300 level class. I couldn't imagine what this class was like. That was my second choice, either to take this class or as far as I could, take this class and what I still needed. Good point. Oh, yeah. Yeah.
I heard there's a potential for
A BP slot.
Yeah, I don't know how to do that. Big rumors are floating.
Yeah, that's what I heard. I don't know if he would go along with that. I don't think he would.
But if you watch his debater and debates, there's been like this kind of uniform
Alliance between them.
If you notice, they're not attacking each other. They're both attacking everybody else, but they're not attacking each other. And
I don't know how I feel about that because I don't like Romney.
That's kind of the feeling I'm getting from everybody I know that's in his base. Is the same things until of the others least. So I'd just be interested to see how that affects the base. You know what I mean? Because I think that sentiment, at least among the small sample people I know, is pretty much the same. One of his friends is like, because he pretty much doesn't call me not just on me. So he not on me. So then he's kind of going, he's interim,
Where's the thought? From my perspective, do you want one good apple and a bucket full of bad apples? That might make a difference. But principle-wise, he has nothing in common with Romney. I don't understand being pro-life and always pro-life. But then he's cool with having a bunch of fake wars that really don't serve any purpose. So, don't kill them. Go ahead and kill the stupid war. But it's like a midterm type test. How long are these tests again? Just like a quiz or something?
I have not.
take home?
They're taking on 10 to 30 hours a week. It's been ugly. Yeah, so imagine that.
That should be a 10-unit class.
That's what we said that too. We said, wait a minute, this should be worth like 10 units. The workload is insane. So,
Do you already get it, or are you doing it now?
every week, we've got one every week.
Well, he'll be the dean next semester, so you
So yeah, I know. Who do you even go to?
Department
Like,
chair.
we're going to go talk to a supervisor. Oh, wait a minute. He is.
It's not the dean.
No, I know.
It wouldn't bother me.
I know the dean, but you know, I don't know how much you know about Quaylor, but if you rock the boat too much, then you're subject to public humiliation. So, is that really the road you want to take?
Right.
Trust me, I thought about that.
You should have taken this public finance class instead.
I already did it. Yeah, I've already taken. I met Wes my first semester here.
I mean, Paul, he's an amazing teacher, but the expectations are just off the charts.
In this class, I think they're too much, but what do I know? Yeah, except for this. Will you agree with me that those that are in this particular class this semester are probably the best students in the department? The smartest, the toughest, some of the best that are in the department.
Right.
And he's punishing them. So
what's your problem?
we complained.
He gave them more work.